Let's add more question on that. Yes, members? Yes? Hello?
Yes, teacher.
Sorry. I was doing something little here, but I've
Yes,
finished.
teacher.
I've finished. So,
Okay.
question number two. Let's write this question down. It's not on the screen. I'm going to write it down and then we move together, okay?
Okay.
They said an object 100 centimeter away, 100 centimeter away from a pinhole camera, from a pinhole camera, forms an image on the screen, full stop. Given that the size of the image is 0.6 centimeters and the size of the object is 0.01 centimeters, comma. Members, are we together? Are you following me? Calculate the distance of the screen. Calculate the distance of the screen from the pinhole. Members, are we on that? Members, are we together?
Yes.
Good.
Yes.
Have you finished?
Yes.
Have you written the question down?
Yes.
Good. Let's look at it. Let's look at the solution. So members,
Yes, teacher.
can we collect our data? When you look at the question, they've said an object 100 centimeter away from a pinhole camera forms an image. That 100 is for what? What is that 100? That is object what?
Distance.
Object distance. Good. Object distance. Which letter do we use for object distance? We use letter what? U. Equals to 100 centimeters. Forms an image on the screen. Full stop. given that the size of the image is 0.6 centimeter, what does that mean? What's that size? That size is meaning what? The height, not so.
The height, yes.
So that is the image.
Image height.
Image height. Image height. So we use HI. Was given to be what? 0.6 centimeters. And the size of the object is, so object height was also given, to be 0.01 centimeters. So they're saying calculate the distance of the screen from the PQ. What is that distance, remember? That distance is called what? What is that distance?
Image distance.
Image distance.
So that's the image distance.
Shall we?
The image distance, which is V, was not given. So now,
Teacher,
yes?
which question are we doing? I've just joined right now.
We have written the question. We have just finished writing the question down, but I will show you, okay? Okay? So what are we going to do, members? What are we going to do from there now? Yes, members, what are we going to do from there?
We calculate the magnification.
We calculate the magnification first, not so?
Yes.
Even before you go and look at calculation, before you go start looking at the formula, make sure that all of them have the same units, have the same what? Units. So this is centimeters, centimeters, centimeters. So all of them are in centimeters. So there are times they give you when they have different units. So make sure that by the time you are using it, you are substituting them. Make sure that they have the same unit. Are you together, members? Yes. So we said using magnification equals to V over what? V over U. Or we know that magnification is also, or M is equals to what? HI over H what? H naught. So which means we shall have V over U equals to HI over H what? H naught. I think that to make it easier, okay?
Yes.
Or what someone can do, you first get magnification separately. After getting magnification, then you come and use this formula. But it's easier when you combine all of them like that, okay? So what do we want? In this case, we want what? We want V. We want what? V. So what do? We make V the subject. We make V the subject by cross multiplying. So when you cross multiply, what do we get? When we cross multiply, members, what do we get? We get V H naught, not so, equals to U H what? HI. So we divide all through by H naught. Divide all through by H naught. So this and this will cancel out. So you find that our V will be equals to U HI divided by H what? H naught. So after that, make the substitution now. V is equals to, what is our U? Our U is what? 100 times. What is our image? This image height? Image height is 0.6. Divide by 0.01. Divide by 0.01. So what do you get? What do you get? So our V is equals to, so our V will be equals to 100 times 0.6 divided by 0.01. We get what?
6,000.
6,000. So that is it. 6,000 what? What's the unit? Centimeters. Okay?
Yes.
Yes. Good. Next Number 3, let's do one more. So are you seeing question number 1 on the screen? Question 1 here. Are you seeing this question here on the screen?
Yes.
Yes, write that question down. Write that question down. Write that question down. A girl is 1.6 meters tall and stands 4 meters away from the pinhole camera, which is 20 meters long. Find the image height, the magnification if the camera is only 110 centimeter long. Can we start?
You are still copying.
Are you through? Yes, members? Are we through?
Yes.
Okay.
Yes.
So can we collect our data from the question? What is given? Let's go through that together. What is given?
Object height.
I've given the object height. Object height was given to be 1 point what? 1.6
6
meters.
meters.
What else was given?
Object distance.
Object distance. Good. Object distance. U was given to be what? 4 meters.
Image distance.
Image
Distance.
distance. Good. Image distance. Image distance. V was given to be what? 20
meters.
20 meters. Then what do they want in Roman 1? Roman 1. They want the image.
Height.
The image height. So are we going to find the image height? By first getting what? Magnification, not so? We first get what? So from magnification equals to V over what? Over U, which implies that M is equals to So our V is what? Members, what is our V? Yes?
What does M stand for?
M is standing for magnification. Magnification. You have just joined today.
Yes, I didn't attend the previous lesson.
So after the lesson, go and watch the videos for the previous lesson, but let's go through this together, okay? M is standing for magnification, okay? Magnification is the ratio of image distance to object distance. That's why we say is V over U, okay?
Yes.
Yes. So members, what is our V? Our V is what? 20 meters. Divided by our U, which is it? 4? So this and this will cancel out. Therefore, our M is equals to, we get what? 5 what? 5. Is 5. Ask no unit. Ask no unit. Okay?
Yes.
So that's not what they're asking for. You come and say, but magnification also equals to what? H what? HI over H what? Over H naught. So it implies that our HI is equals to what? M H what? H naught. If you make this one, because we are looking for this one, not so. We are looking for the image height. Okay? So when you substitute, what do you get? So we shall have our magnification, which is 5 times the image height, which is what? 1.6 1.6, which means it's going to be in what? In meters. So HI is equals to, what do you get? What do you get?
8.
So it's around 5 times 1.6, which is going to give us 8 what? 8 what?
Meters.
8 meters. 8 meters. Underline that. Underline that. This is calculation. Underline that. Roman 2. In Roman 2, what do they want? They want the magnification if the camera is only 10 centimeter long. If the camera is only 10 centimeter long. What is that centimeter long, remember? What is that? What is that?
Image distance.
That's the image distance. Good. So that's the image distance. Image distance was given to be what? 10 what? 10 centimeters. But now when you look at our object distance, everything here was given in what? In meters, not so?
Yes.
So which means you have to convert this one to meters first before substituting. So when you substitute that, that one is going to be the same as, this one is equivalent to, we divide it by what?
100.
By 100. So when you divide by 100, so which means it implies that our V will be equals to 0.
10.
0 point what? 0.1 meter. So from M equals to V over what? V over U. So our V we got is 0.1 meters. And our U, we still remain what? For what? We still remain what?
Meter.
4 meters. Because they have not given us a new statement. So M is equals to 0.1 divided by what? Divided by 4. So what do you get?
0.02.
0 point
02.
0.02 to what?
5.
To 5. Okay?
Yes.
That will be our magnification. So what does magnification tell us? Magnification will tell us the nature of the image form. The nature of the image what? Form.
Form.
Whether it's diminished or magnified. Members?
Yes, teacher.
If magnification is less than 1, if the magnification is less than 1, it means the image has been diminished. Been what? Diminished. But if it's more than 1, which means the image has been what? Magnified. Are you together?
Yes.
Yes. Takes note of that. Takes note of that. Is there any question on how to calculate magnification and how to with it related concept? Is there any question on that? I think we are together on that.
Yes.
All right. All right. Like the questionnaire is saying, what is meant by rectilinear propagation of light? That one we can answer it. They said an opaque object is placed in front of a source of light. Draw array diagrams to show the formation of shadows when when it's from a point source of light. We said when light is from a point source of light, from a point source, which type of shadows does it produce? Which type of, it produces only what?
Umbra.
It produces only umbra. Good. You should know how to draw that. When it's from extended source, what does it produce? It produces both shadows, no sir? It produces both umbra and penumbra. Penumbra. We have also looked at solar eclipse. All the things we have looked at them. Okay? We have looked at all of them. But before we go to this, let's look at something briefly. Yeah? Okay?
Yes.
Before we go to reflection, let's look at something brief. Remember we said one of the nature of the image formed by a pinhole camera. Who can remind us? The nature of the image formed by a pinhole camera. Who can remind us? Nature or characteristics? Nature or the characteristics? of the image formed by a pinhole camera? Who can remind us?
The image inverted.
The image is what?
Real.
The image is real. Good. The second one is it?
Inverted.
Inverted. What is the opposite of what's the opposite of real? Is what?
Real.
What's the opposite of real? Is virtual, not so?
Yes.
The opposite of real is a virtual. So sub-heading, let's look at that. So let's look at the difference between real and virtual images. So sub-heading, real and virtual image. Real and virtual image. What's the difference between them? I remember explaining this one the other time. Who can remind us? What did we say real image is? Who can remind us? Yes? Patricia?
Yes.
Yes, what is the real image?
The teacher, you said a real image, as in it does not change. It just looks the same. Yes, for example, if you're looking at yourself in a
Yes, Patricia?
yes,
What were you saying?
I was saying that a real image. Okay, so by the object appears the same. It does not change. For example, if you're looking at yourself in a mirror, that image appears to be real. It does not change.
No. Patricia, you are lying. You are lying.
I don't.
You are lying. Okay, members, when we talk of a real image, okay? A real image is the one which is formed on the screen. Is formed on the what? On the screen. Because if, take for example, you are looking at yourself through a dressing mirror, like Patricia was saying, you see that when you are 5 meters, when, take for example, you are 20 centimeters away from the dressing mirror, you find that your image will also appear to be 20 centimeters away behind the mirror. So you see that it's not on the screen. It's not on the screen, but it's behind. They seem to. Okay? You get? So that image that is formed on the dressing mirror is not real. It's not the real image of you. But it appears to be real, but it's not real. Okay? It's an illusion of you. Are you together, members? Okay?
Let's put on the explanation.
The real image must be formed on the screen. It must appear on the screen. Okay? Are you together? A real image must be formed. Let me write it down here. We said a real image is one formed by the actual intersection of light rays, by the actual intersection of light rays, and it is formed on the screen, and is formed on the screen, Right together? Yes. So that image is what we call the real image. The one which is formed by the actual intersection of light rays. But when you look at the one which is on the dressing mirror, the one you use at home, plain mirrors, the image is not real because the image appear to be behind the dressing mirror. So which means is not the actual intersection of light rays. It's apparent intersection of light rays. Okay? Are you together? Yes, take note of that. Take note of that. Let's see how we can draw it. Let's see ray diagram. Let's look at ray diagram for that. Ray diagram. Members, are we together?
Yes.
Let's draw this ray diagram. So if this is a reflecting surface, take example, a plane mirror. We have something here like this. It's reflected there. So the image will be formed there. So that's the image. And this image is the real what? Image. Okay?
Yes.
Yes. Members, not all plane mirrors form virtual image. There are some, it depends on how you place the mirror. But as long as the rays from the plane mirror can be formed, can meet together by the actual intersection of that rays. If the actual rays can meet together, it will form a real what? Image. Are you together?
Yes.
Yes. So this is a plane mirror. It depends on how you place it. It depends on how you position the mirror. So take note of that. Red light from coming from here is reflected back there. Here also coming, and you find that the light rays, the reflected rays, are meeting and at a common what? At a common point. So the image that is formed through the actual intersection of light rays, that image is called what? Real what?
Image.
Real image. Good. The second one, let's look at the second one. Virtual image. Virtual image. Virtual members, virtual what?
Image.
Who can give us that? Who can give us that? It's just we said it's the opposite of real. So for real was what? Real is formed by the actual intersection of light rays and it is formed on the screen. What about virtual now? Who can give us virtual? What is a virtual image? Yes, members? Who can give us that? I remember talking about it. Who can give us that? Patricia, I did not understand your message you have sent. It's not clear, Patricia. Who can give us now that? Okay. A virtual image is one that is formed by the apparent means something is not real, by the apparent intersection of light what? Light rays. And it is not formed and is not formed on the what? Members, is not formed on the what?
Screen.
On the screen. Are you together?
Yes.
So is apparent. The key word here is what? Apparent or seem. If you don't want to use the word apparent, you can use the word seem to appear. Okay? Okay? Yes, if you don't want to use the word apparent, so you can say is the image formed by rays of light that seems to appear on the screen, But what is important is the word, since we put the word seems, which means is not on the screen. That is apparent, it's not real. Okay? Are we together, members?
Yes, teacher.
Yes, let's look at ray diagram for that. Take example now, you see now this time I'm going to position a plane mirror differently. Are you seeing that? This time I'm going to put it like that. I'm going to make it stand vertically. I'm assuming I have an object here. This is an object. I have an object there. Which is in front of them. So ray of light from the object. Ray of light from the object will come like this, like that. Because remember there are very many rays coming up, okay? So, but I'm just taking few of that. So you find rays of light will come like that, like that. Members, are you following me?
Yes.
Members, are you following me?
Yes, teacher.
Yes, teacher.
Good. So once it get to the mirror, it's reflected. From there is reflected. And this one is reflected. So make sure that this one is in straight line. Make this one continue like that. So this is now behind the mirror. You see that? You see that the rays seem to. You can see that. So this is where the image is. This is the image. Members, have you seen that? Here is reflected back. Is reflected back. Now for you, you are here. You are here. You are seeing it from here. The observer is there. Members.
Yes, teacher.
Yes, please. Are you getting me?
Yes.
So this is the object. This is the object. Then this is the image. This is the image. Then this is the plane. Plane mirror. Members, have you seen that?
Yes.
Yes, please. Can you talk to me? Members, are we together on that?
Yes.
Yes.
Fiona, please, can we unmute and you talk to me, please? We have few minutes. We have just seconds to go. Are we together on this?
Yes.
Yes, teacher.
Lynette, Daisy,
Yes, teacher.
you're talking, but I can't hear you. Daisy, you're talking, I can't hear you.
Teacher. Yes, teacher.
Is it clear?
Yes.
Very good.